This is section 5.2 in your textbooks, page 264. We're talking about different forms of the equation of a line. We've already talked about this and seen this quite a bit. Okay, we don't always get the information or the equation of the line in that form, y equals mx plus b. However, that is the form that we do want to see all the time, because when we rearrange it for this to become in this form, we can easily see the slope and we can easily see the y-intercept. So again, just to remind you, this is the y-intercept and this value here is the slope. Okay? So it's important that we practice rearranging formulas to keep y on the left-hand side and the x variable on the right-hand side. That way we'll rearrange it to have the formula y equals mx plus b. So the first example, it says there's 24 meters of fencing. What are some possible values for L and W? Okay, so the first thing with this problem is that we notice, typically what we notice for perimeter, right, in a regular rectangle, perimeter is equal to 2L plus 2W. Okay, but there's a difference with this particular dog pen that we're creating actually. Anybody tell me what the problem with this formula is for this example? Just Austin, yeah?
There's 3 widths.
Yeah, there's 3 widths, okay? Because we need a piece of material to make up that width as well. So it's actually 2L plus 3W. Okay? So that's our equation. What am I going to sub in for P? Michael, right here. Michael. What can I sub in for the perimeter here?
24.
Good, 24, because they tell us that we have 24 meters of fencing. So this is the equation we get. Okay? And now just to simplify things, or to make things a little more to what we're used to, let's sub in, instead of L, let's call it Y, and instead of W, let's call it X. Okay, and that just makes it a little more familiar to us. So this is W, and this is X. Okay? I didn't change anything, I just changed the letters. Alright, so now we want to rearrange, so Y is on the left-hand side by itself, and everything else is on the right-hand side. So we have that equation y equals mx plus b. So if I'm going to move this over, I'm going to get negative 2y. Okay, the last step, I need to divide everything by negative 2. So I get y is equal to negative 3 over 2x positive 12. Okay? So right away now I have an equation for a line where my x value here, sorry, my slope is here. This is my slope. And here's my y-intercept. The question asks us, what are some possible values for L and Y, or L and W? And we've changed these to X and W. Okay, X and Y. Now what can I do? I have an equation here. What's the next thing I can do now? If I want to just have some possible values. Michael?
So you can solve for x.
I could rearrange and solve for X. Yeah, I could do all that. Or I just want to have different values. Josh?
Could you just solve it mentally? Like the length and all
No?
that? And then,
No, what do I want to do here? I want to have it saying different possible values, because there could be lots of values. Michael?
Plug in any value for x.
Good, excellent. Plug in any value for X. So I'm going to choose my X value and then measure my Y, right? So X, the first value I might want to try is 1. It wouldn't make sense to go with 0 because then there's no width at all. So I'm not going to have much of a playpen if I don't have a width. So if we go with 1, then we'll get negative 3 over 2 times 1 plus 12. All right? That's equal to negative 1.5. So we have 10.5 is our Y value. So there's one possibility, right? Our width would be 1, right? And our Y value would be 10. 0.5. Okay. Another possible value I can sub in for X. Let's sub in 2. So we sub in 2, negative 3 over 2 times 2 plus 12. These 2's are going to cross out. We're going to have negative 3 plus 12 is 9. Okay, so there's another possibility. My width is 2, my length is 9. Any questions there? And so on. We can plug in 3, plug in 4, we could even plug in 100. Okay, if we wanted, or any number, and then figure out why. Any questions with those? So once we've rearranged the formula into this format, y equals mx plus b, then we can easily solve for our y values by plugging in an x value. If we leave it in this format, it's possible we could also do it, plug in a value for x, but then each time we're going to have to be rearranging to solve for y. So it makes sense to do it first, rearrange, solve for y, and then plug in your x values. Okay? All right, example 2. It says determine the slope and the y-intercept. So basically what it's asking us is to rearrange that's what it's asking us to do, right? Rearrange to y equals mx plus b, because once we do that, we can then obviously know the slope and the y-intercept. So first things first, I want to move everything away from the y value, keeping the y on the left-hand side. Yeah.
So it doesn't matter if you do negative 8 minus 3x?
No, but you want to have it in this. You want to have it in this format where the x comes first. It just looks nicer. Doesn't matter. It's still technically right if you realize that the x-intercept is or the y-intercept is in front. But it's good to get into the practice of putting it in that order. Yeah.
Wouldn't it be negative 2?
No, because it's. Sorry, you're right. Yeah. Thank you. Negative 8 divided by 4 is negative 2. Yeah.
Oh, never mind.
Any questions with that one? So then I know what my slope is. My slope is equal to negative 3 over 4. And my y-intercept is equal to negative 2. Okay, so you guys should be able to mentally graph this. Like right away, you should be able to kind of visualize what this is telling us. It's telling us my y-intercept is down here. And I'm lowering 3 for every 4 that I run. So 1, 2, 3, I'm coming down here. 1, 2, 3, 4.
People that already did grade 9, that what they did is that they extended that you can extend it more to find more points by multiplying it by something.
Yeah, you can just keep going with the slope to get more points. So if you want to get another point from here, then you just lower 3 and run 4 again.
Oh, you just do that?
Yeah. So I don't know if that's what you mean to by multiplying it, but yeah, you go down 3, go across 4, there's another point. In this case, you'd have to go up 3 because you're going to the left 4.
Yeah.
Right? So your point would be over here. Yeah. All right. Any questions with example 2? Okay, last one, example 3. So Sam works at a grocery store and a library. He makes $8 an hour at a grocery store and $10 an hour at a library. He says he wants to save $280. Determine the fewest hours he needs to work. He wants to make $280. What's the obvious answer? Josh already knows it.
28.
Sorry?
28.
Yeah, why?
Because 10 times 28.
Yeah, obviously he's just going to work at the library, right? That's a pretty obvious answer. I'm not sure why the book chose this particular question, but it does go through the process of rearranging it and solving for it in terms of one variable in terms of the other. So we're going to go ahead and do that. So let's say we want to determine, so this is my grocery hours, so I get $8 every time I work at the grocery. So G represents the number of hours I work at the grocery store. L represents the number of hours at the library. And I make $10 per hour, so 10 times L. And that all has to equal 280 because that's what we're looking to save. Josh?
How about instead of doing like the fewest hours, why don't you just put like a set number of hours? That way we can do like that. I don't know, if let's say if it works 30
I'm
hours.
just going to do it the way it's intended. Okay, because if you say a set number, then it would also change that value too, right? 280. All right, so we're going to rearrange this in terms of L. All right, so we'll leave 10L on this side. We have 280 minus 8G, and L is equal to 28 minus 810G. I'm going to rearrange this, put this variable in front, and 8 becomes 4/5. Okay, so now we have this equation where we have our library hours in terms of our grocery hours. And we can do a quick table of values, plug in values for G and figure out L. So if we plug in the first value, G is 0, we find out L is 28. We plug in a value of G is 1. We're going to get 27 1/5. Plug in G is 5, we get 24. Okay, so when we do it this way, we can see that our number of grocery hours, we figure out how many library hours we have to work if we work that many of grocery hours, all in total to make $280. Okay, but remember, the fewest hours he needs to work, we need to add these two values up. So 0 plus 28 is 28. 1 plus 27 1/5 is 28 1/5. 5 plus 24 is 29. So we can see as our grocery hours go up, our total number of hours is also going up. So obviously the best scenario is we work 0 hours at the grocery store and the least amount of hours is going to be 28. This is total hours worked. Okay? Pretty obvious from the initial question, but just to show you the math involved. Yeah.
So is the minimum wage like $12?
$10.
It's 10?
So then shouldn't $8
Then they-
an hour,
then they
shouldn't
raise
that be
it.
illegal?
You might get commissions at the grocery store. We don't know. They can pay you less than $10 an hour if commissions are involved.
And also.
So like I think waitresses get less than $10 an hour. Yeah.
Isn't minimum wage still under the poverty line?
Is it? I would say so. Maybe. Yeah. Yeah.
Yeah, but if it's
That's
All right. Any other questions with the lesson?
annual, it's all-
Not related to the poverty line. Nobody else? Okay, that's the end of the lesson.